Okay, college readiness students, this is the Unit 1 Quiz 1 review, so feel free to go through this as quickly as possible or go back and watch this over until you understand everything. All right, so first thing out of the box is we're trying to classify this sequence as arithmetic, geometric, quadratic, or cubic. Now, if you remember in class, the first thing I told you is we need to figure out what is geometric. All right, remember geometric is multiply. So that's the weird one. All right. So you got to look and go like, okay, am I taking 97 and am I multiplying something to get the 74? Well, 97 times, not a whole number will not give you 74. So that's not going to work. So we know that question number one is not geometric. So we start subtracting or finding the difference. So 97 and 74 is 23. 74 and 51 is 20 minus 23 minus 23 minus 23 minus 23. So we're subtracting 23 every single time. So that means it is an arithmetic sequence. Now, the next step is to determine the next number. Well, if you're subtracting 23 every single time, to get the next number, you obviously know you have to subtract 23 to get negative 41. Okay? Now, for this next question here, again, remember that before you start determining what it is, you always have to look to see if it's geometric. Geometric is that weird one. So you look and go, okay, 1 and 6. Okay, well, 1 times 6 is 6. Well, here's a question. 6 times 6, does that give me 36? And the answer is yes. So I'm finding a common theme amongst this where I'm multiplying by 6 every single time. So that means it is going to be geometric. All right, had a pause for the announcement. All right, so that means I'm multiplying by 6 every single time, which means it's going to be geometric. Now, to figure out what the next term is, again, I'm just going to take 1296 and just times it by 7,766. All right, there we go. All right, next thing, again, I know that geometric was this one here, but we still need to treat this one as if like it could be geometric. All right, so first thing out of the box is I always like to look at my first two numbers. 8, can 8 times anything equal 20? And the answer is no. 8 times anything does not equal 20, so I know it's not going to be geometric. So I'm going to start subtracting. So 8 is 12. This will be 20. This will be 28. This right here will be 36. This right here will be 44. Remember, you keep going until you find a common term. All these numbers are different. We keep going. 20 and 12 is 8. 8, 8, and 8. There we go. There's my common term. So to figure out what the next, well, actually, I found my common term on the second level, which means it is going to be quadratic. Now the question is, what's going to be my next term? Well, if you remember in class, I taught you a shortcut, and that is if you take these numbers at the very end of each row and add them together, that will give you the next term, which the next term would be 200. And then this one right here, again, look at 13 and 61. Is there anything I can multiply to 13 to get 61? The answer is no. I cannot do any of that, so I am going to start finding my differences. So this ends up being 48, 116, 214, 342, I believe. We're going to keep going. This ends up being 68, 98, and this ends up being 128. And then we have 30 and then 30. Okay, we went down to the third level, which is cubic. So again, to figure out that last term, we're going to take each number on the end of the row, add them all together, and our final answer is going to be 1,233. There we go. All right. Writing a recursive rule, if you remember in class, basically whenever I say recursive rule, it is A of n is equal to A of n minus 1 something. That something means what am I doing to the previous number to get to the first number or the next number. So if you notice, I'm starting at 2, now I'm at 12, and now I'm at negative 72. Here, what am I doing? Well, I'm timesing by negative 6. So that means in order to get to my next term, which is a of n, I'm going to take my previous term, which is an minus 1, and times it by negative 6. For the next one here, let's see, 30, 170, negative 170, I mean, let's see, what are we doing? What are we doing? All right, let's see. Oh, I'm subtracting by negative 200. So my common difference is negative 200. So I'm going to say a of n is equal to a of n minus 1 minus 200. I'm subtracting 200 from my previous term to get my next term. My next one, I'm just going to speed up. I'm going to times it by 3. So again, in order to get my next number, I have to take my previous number, which is an minus 1, and times it by 3. And then my last one, 38, 43, 40, I am adding 5. So my common difference is 5. So that's going to be, in order to get to another number in my sequence, I have to take the number before it and add 5. All right. For this question here, all right, so for question number 5, I had to pause the video, so I don't know where I'm at now. So question number 5, it says state whether the sequence is arithmetic or geometric or neither. Remember, arithmetic is when you're adding consistently. Geometric means you're multiplying consistently. So if you notice for question number 5, you are multiplying by negative 6. So your R would be negative 6, which means you're dealing with the geometric ratio. Here, you're adding 5 every single 5. So 5 every single time. So our common difference is 5, which means it's arithmetic. All right. Now, if you notice here, negative 2 to 1, you're adding 3. Here, you're adding 3. I'm sorry. No, I'm sorry. Ooh, sorry. I totally messed up here. So let me clean this up. All right. So negative 2 to 1, you're adding 3. But then from 1 to 6, you're adding 5. So you're not adding the same number, which means you're dealing with the neither situation. It's neither geometric or arithmetic. This one here, if you notice that you are multiplying by 4 every single time, so my ratio would be 4, which means it would be geometric. All right. Question number 9. All right, so we did this in class where we're dealing with the rhythmic sequence. All right, so if we're dealing with the rhythmic sequence, remember the rules. And the rule is, for one, let me make this a lot smaller here. For step 1, when you're dealing with an arithmetic sequence, you are going to take the later term and subtract by the early term. Okay, that's step 1. And then step 2, you are going to divide by the jumps. Okay? So that's what we're doing for this one here. So we're going to take the later term and we're going to divide it. I'm sorry, we're going to take the later term. So in this problem here for question number 9, the later term is negative 139. So negative 135, sorry. And then I'm going to subtract negative 35. So remember that they're double negative here. That goes positive, positive. That gives me 100. Okay? Now, divide by the number of jumps. So I'm at negative 35. 1 jump, 2 jump, 3, 4, and 5. 5 jumps, 100 divided by 5, which gives me 200. Wow, I'll say it right. Which gives me 20. So that means I am adding 20 every single time in this sequence. So negative 35, my next one will be negative 55, negative 75, negative 95, and then lastly, negative 115. There we go. Now for this next one here, same exact thing. First step, I'm going to take 96 and subtract it by 36, and I get 60. And I divide by, let's see, 1, 2, 3, 4, 5. Oh, divide by 6, 6 jumps. So I'm going to divide this by 6, which gives me 10. So that means I am adding 10 every single time I'm going through these. I'm adding 10 every single time I'm going through all this. So this would be 46, 56, 66, 76, and then lastly 86. There we go. Next one, find the missing term or terms. So now we're dealing with geometric. So if you remember, again, in geometric, you are then going to take the later term. So or step 1 is take the later term and divide it by the early term. That's step 1. Step 2, you're going to take of the root of jumps. Okay? So first thing out of the gate is my later term is negative 243 and my early term is negative 1. So negative 243 divided by -1, which gives me positive 243. Now, how many jumps do we have? 1, 2, 3, 4, and 5. We have 5 jumps. So we're going to take the fifth root of 243. We're going to take the fifth root of 243. Now, you should know how to do this based off of the times that we spent, but if you don't know how to do it, make sure you ask me to take the fifth root. So when you take the fifth root, it ends up being r is equal to 3. So that means I am multiplying by 3 every single time. All right, same concept over here. 1458 divided by 2 gives me a number I don't know off the top of my head. Let's see if I have this going. Let's see, 1458 divided by 2. That gives me 729. So 1, 2, 3, 4, 5. Oops, that's 6 jumps. So I'm going to take the sixth root of 729. And again, I will, and I believe that's going to be 3. Yes, I believe that's going to be 3. So R again is going to equal to 3. So since I know R is equal to 3, that means I know that, let's see, so that's going to be multiplied by 3. That's 6, 18, 54, 162, and then lastly 486. Okay. So that's going to be part one. I'm going to go ahead and stop right here just because of the fact that I don't want to make a video that's like 30 minutes long. But that's going to be part one. Stay tuned for part two.